Okay, in this video I'm going to continue on with exercise 5b of the book Fundamental Applied Mathematics. We're on page 130 and the question is 5. So we're now on to a new type of question and we're dealing with pulleys. So it reads, a fixed smooth pulley has mass 2 kilos and 5 kilos hanging freely from either side by means of a light, inextensible string. The system is released when 2 kilo mass is on the horizontal floor and the 5 kilo mass is 2 meters above the floor, so as to find the common acceleration of the two masses. Now notice here, by the way, this time he says we're talking about a light, inextensible string. So if you haven't seen my video on the massless rope, please watch it. I think that's very important. And also watch my video on Newton's third law. Both of those videos go together and I think they're quite important. So for the first time in this chapter, he's actually given us the information which fits into this. And we're told that the rope is light, therefore it has a mass of 0. So let's just sketch the motion first of all and draw our free body diagram. So there is the ceiling. We have kind of a bar hanging down, and we have our pulley. Okay, so our pulley goes something like this, and on the pulley we have two ropes, one like that and one like this, and off them we have masses hanging off both of these like that. Now the thing is, in actual fact, I think it's easier if you draw really small masses, small weights we'll say. Just makes the diagram a lot easier to do. Alright, these diagrams can become very cluttered very quickly. Alright, and we know that the 2 kilo mass down here is on the ground. So let's just begin by putting in all the forces and so on that we know of. And I've defined my unit vectors as normal. So the gravity vector, we know g, it's going to be minus g, j hat, like so. And that's an acceleration. We know that this here is 2 kilos, so its weight is going to be equal to negative 2g j hat. This one is going to be negative 5g j hat, like so. We know the distance from the 5 kilo mass down to the ground is 2 meters, like so. Do we know anything else? We don't. Now of course this string is one continuous string. So now, for reasons I've said in my video on the massless rope, if you have a rope being pulled at one end, and if it's massless, and only if it's massless, then the same forces on the other side. So you might call them T and T, or T1 and T1, or T12 and T12. But they're only equal if the mass is 0, and these aren't Newton's third law pairs. This is not an equal but opposite reaction. This is only as a result of the fact that the rope is massless. That is vitally important. Because while you might get away with it in a leaving cert like this, if you go into college, then you will really be struggling if you believe that. So we're not into preaching heresy here. So let's see what we can do. We need to find the overall forces. So if there's a force here, that's a tension. That means there's a tension here as well. That's a tension, like that. And what else can we do? Let's just talk about the 5 kilo mass first.